Hello viewers, welcome to my YouTube channel. My name is Oluwashina Oyenira. Today in this video, I will be talking about recursion. Uh, Recursion is a way of solving problems where the solution involves solving smaller instances of the same problem. Uh, Take for an instance is a kind of nested boxes in such a way that each box has a smaller boxes inside it. So it's like you are trying to find stuff for something by opening the boxes. So by the time you open the first box, there's another box inside of it until you reach the last box that has the solution to the problem or what you are looking for. That is recursion. So in order to get this done, there is a need to implement a recursive function. So in a simple term, a recursive function is a function that call itself during its execution to solve a particular problem. So it's a function on its own, but it call itself to solve a particular problem. So I'm going to be using the factorial problem to implement recursive function. So I have a snippet here to demonstrate this, and I want to believe you know how factorial work. So if you don't know how factorial work, I'm going to show you. I have an equation here. I have an equation here. This is how factorial work. This is the general factorial equation. Yeah, so this is factorial equation. So take for instance, if you are looking for 5 factorial, the implication is that we are going to have 5 uh, multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. This is the solution to this problem of 5 factorial. So if I want to implement this in Python using a recursive function, how am I going to get it done? So I have a snippet here, and let's see what my snippet is going to do. Okay, so this is my snippet. The first thing I do is to define factorial of the function of n. So this is going to calculate the factorial of any number using recursive. So there are 2 parameters here. Sorry, yeah, there's only one parameter. We have the n, which is a non-negative integer whose factorial is to be calculated, like what I show you here, 5. So you're going to regard n as 5 here that we are looking for. So if we run this code, it's going to return the factorial of n to us, but let it have it at the back of your mind that the 0 factorial is equals to 1. Yeah, so anytime you are looking for the factorial of 0 is always 1. So if you try to use this, it's going to return 1 to you by default. So look at this code. So if n is equals to 0, then return 1. Otherwise, calculate the factorial. So how are you going to do that? So let's see what this is going to do. So if I run this code, it's going to return 120 to me, which is the factorial of 5. Now what exactly do we do here? Now what this code did is to check for n. What is the current value of n? Is n is 0 greater than n? Yes, 5 is greater than n. Then calculate the factorial, and the factorial is n minus 1 in this regard. So n to 1. So this is what is calculated. So there is already an inbuilt factorial function in Python that get this done. So this particular code is the shortest method of calculating factorial. In the subsequent video, I will be talking about something else. I will be talking about dynamic programming. But before we do that, let's check one more example of recursive function in Python. And in this regard, I will be you're using a recursive function to calculate Fibonacci series. So, how does Fibonacci series work? So, Fibonacci series, if you start from, it will take two number and add this together to give you the another number. So, take for instance, if our initial number is 0, then we have 1. So, definitely the next number is still going to be 1 because it's going to add 0 and 1 together. So then what is the next number? The next number is going to be 2. Then what is the next number? It's going to be 3. The next number is going to be 2 plus 3, which is 5. While the next number is going to be 8. So this is how Fibonacci series work. So sorry, this is supposed to be 8. This is how Fibonacci series work. But how do we do this using a recursive function? So I have a snippet here as well to demonstrate that. So if you look at this code, it's going to calculate the nth factorial, Fibonacci number using recursion. There's only one parameter as well, and then this is the position. This is n, which is the position in the Fibonacci sequence, and it's going to return the Fibonacci number to us. So if you look at this, the first thing to calculate is our n less than or equals to 1. If our n is less than or equals to 1, then you have to return n. Else, the recursive function is going to sum of the two preceding Fibonacci number and then return the number to us. So let's see what we are trying to find here is the Fibonacci numbers of 10. So let's run this code, and you see the first number is 0, then 1. 0 plus 1, it gives us 1. After that, we had 1 plus 1, 2, 1 plus 2, 3. And if you count all these numbers together, it's going to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is how Fibonacci series work in this is how recursive function work to create Fibonacci algorithm. So if you look at this, so this is the main recursive function here. So it's a particular function. You see, we declare a function here, then it's calling another function within that. So this is how recursive function work in Python. So in my next video, I'll be talking about dynamic programming. Stay tuned. If this is your first video, I will advise you to watch my previous videos. I have a lot of them that is going to take you through the fundamental of coding. You're going to like them. I would like you to subscribe to my channel for more interesting video. Like, share with your friends and family, and turn on the notification bell. Thank you. See you in my next video.